Welcome back. I'm George, and today we're going to build a PID controller for two elements. I'm using the MyPin TA4, although you can use the Inkbird. You can use just about any one that you can rely on. So, this is the beginning of my build so far. I just wanted to show you this briefly. This is sort of like the teaser. Here's where my elements will plug in. That's my two solid state relays. Oh, I got a lot going on. We now have a finished product, and I'm going to show that to you. And this is my PID, my dual element PID, all assembled. And you see I got my volt amp meter here so I can keep track of that. And of course I could always use the PID. It has a power output mode that you can track as well. But here's how this works. Here's my, you can see the light goes on and off. That's the accessory for my water pump. This is my main power for my PID. And when I turn that on, I rewired it different so the fan would come on when I turn the PID on. That's really the only time I'll need it anyway. And these are my controls for, this is heater element number 1. And you'll see that it's flashing because it's requiring some heat or power. And here's number 2. And so now these lights will indicate every time that that element is fired. And every time my PID fires, these lights fire. So that's just a visual indicator, and it's, matter of fact, there goes my cool points. So if you're interested in one of these, just let me know, drop me a line, call me, or send me an email, and we'll talk about the requirements and specifics, and of course, the type of plug that you need to put on the end of this in order to plug it in. But what I wanted to explain in detail was the necessity for two elements in a still. When is it required, and when is it just, well, when is it optional? So as I'm getting ready here, make sure you subscribe, please. And for those of you who aren't subscribers and you're watching this for the first time, look, it costs you absolutely nothing. Just hit the subscribe button. It really, really helps the channel, and it promotes the channel. So that's the only thing that we ask that you do. Of course, share us with your friends. All right, now when you have a still, and we're just going to draw one great big still, and without any of the additions on it. Now we're talking about heater elements because you're going to use a PID controller to control the heat. And so normally you'll put it in about 2 inches, 3 inches from the bottom. And then that way your element, however it is designed, heats and will heat everything inside here. Now that's with just one element. And what's that good for? It's up to about I don't know, about 15, 16 gallons still. Works extremely efficient. Now when you get a little bit higher than that, sometimes you need some additional help. And that's only during the heat up process. So what we do is 2/3 of the way up, we'll put another one. Now this second one is normally on what we call a static line or a static circuit. And what that means is that there's a plug here that you plug in somewhere, and then once it's heated up, you disconnect it. Now, the reason for disconnecting it is because if you have two elements working on the same PID when they're like this, they start to work against each other. Now, remember we talked about that thermal transfer and convection currents and things going on inside the still. Well, if you got it's really hot here, and when it moves up, it's hot. So this one's on, this one's heating it some more. So you see they can start working against each other, especially if they're the same wattage. Now there are ways around this, but why go through that process? Put this on a static line. Now there's another option. We could build a PID controller where this one plugs in, let's take that away, and this one plugs in, and we put a switch here and a switch here. And these switches control heater element 1, heater element 2. And we can either turn it on or turn it off. And that's what we're going to build today. Now, here's the other consideration. Now, when you get up to, okay, you're up to like 50 gallons. Yeah, you're no longer, yeah, you are still hot, you're just still in. You get one of them larger devices, and that may require you to have 2 elements in the bottom. And that's quite all right. So you put two 4,500 watts, two 5,500 watts, two 3,500, whatever the case may be, you can put those in there, still run them both to the same PID controller, and you got the on-off switches. So if something should go what I call cattywampus, you can always turn one of them off or leave them both on. And since they're both at the same level, they don't compete against each other, so you get a much more smooth, much more efficient, much more gentle maintenance of your temperature. See how simple that is? So just remember, if you've got one 2/3 of the way up and it's just helping you heat up, because when you get like 13, 16, or above about 16 gallons, you need that additional help to save you time, because that's all it is a time saver. So you've got that one and you plugged in. Once it gets up to temperature, unplug it. And just rely on the one. If you've got a really large still, put 2 in the bottom. And that'll really help you along the way. Okay? Good. Hey, an update on Mike, our blind distiller. We are working feverishly, but we are really making progress. So for all of you who have commented and lended your support and your assistance, we definitely appreciate it, because we're really, really on the road to success. So let's get into building this PID controller for a multiple element circuit. Now, we've got this box. I've got a larger box that I'm using. This cost me about 21, 22 bucks at Home Depot. And I've got my fan here. I got a 12-volt fan. That will move the air through here to circulate the air to make sure that it remains cool, because I've got 2 solid state relays on heat sinks, and I've got 2 vent holes here and I've got 2 vent holes here. What I want to do is make sure that my holes, the area of my holes, are at least equal to the area of the fan, so I get a constant flow. I'll probably put one more hole here, only to make sure that I've got enough surface, enough area. All right. Now I'm using the PG21, and the PG21 is the size of the gland for this 10 gauge wire. I got 10-4, and there's a reason why we're using the 10-4 as opposed to a 10-3, and that's because, remember, if you've got four wires on a 240 volt system, I can wire 240 volts anywhere in the box, but I can also wire 120 volts for a separate receptacle. And if I only have a 3-wire system, I'm only left with 240 volts. I don't have that option for that 120 volt receptacle. So here's where we go. We've got, I put a connection block in here, and if you look in closely, you'll see that I've got a bridge that bridges these 3 screws together. Then I got a separate bridge for these 2, and a final bridge for these 3. And what that does is it makes these 3 120 volts. It makes these 2 neutrals, and it makes these 3 120 volts, which are out of phase. So that means if I hook this one and this one together anywhere, I've got 240 volts. If I hook this one and this one to something, I've got 120 volts. Or if I hook this one and this one somewhere, I've got 120 volts. You follow the process? It's really relatively simple. Now, I've got 2 50 amp solid state relays. Remember, it's a SSR 50DA. And DA means I'm going to have direct current going into pins 3 and 4 to control an AC voltage between pins 1 and 2. Now I've got that on both sides, and you'll see later on, because we'll take this through step by step, and I'll build these. You just need to call me or send me an email. Here's my email address, oh, by the way. Send me an email on what your requirements are. We'll discuss the price, but I can build these things for you relatively easy. Okay, now the reason I'm using the 50 amp is because I want to make sure it's better to have and not need than need and not have. In this particular case, I'm not going to put anything in here or connect any element on this box that will exceed the value of what it's capable of carrying. And what it's capable of carrying so far, see this 10 gauge wire? That's 30 amps. So with a 30 amp potential, I don't want to exceed that. So this would probably be good enough for 2 3,500 watt elements. Okay, here's a question. Can you hook 2 4,500 watt elements to it? Well, you could, but that would draw at 100% power 37.5 amps. Now it doesn't do it all the time, so can you heat them all? Yeah, there's ways around that, but I'd recommend that you don't. Could you put two 5500 watt elements, plug them into this? You absolutely could, but in that case you'd be drawing 45.8 amps. And that really does exceed the wire, but it doesn't exceed the solid state relays. So that's the reason why I've got these relays in here at 50 amps. All right, so here's my 12 volt transformer, and that's that small IRM 10-12, and that's going to convert 120 volts to 12 volts to operate the fan. Now later on we're going to place in our NEMA L6-30. And the L6-30 is a twist-in plug, and it's only got 3 connectors. So all we need is a hot, and a ground, and that'll be for your element. So stick with us, and we'll keep you updated.